In the early 20th century, if you asked an astronomer which planet was most likely to host life, they would have pointed to our sister planet Venus, which is nearly identical in size, mass, and composition. Venus was a world of mystery, perpetually shrouded in a thick, impenetrable blanket of white clouds, which acted as somewhat of a Rorschach test for the scientific community. We saw a planet closer to the sun with massive cloud cover, and the logic was simple. Heat plus clouds equals moisture. The Nobel laureate Svante Arrhenius argued passionately that Venus was a swamp world. He looked at the data and saw a planet that mirrored Earth's own Carboniferous period, a prehistoric era of endless rain, humid air, and lush, giant vegetation. In his mind, to visit Venus was to step back in time. He theorized a world of colossal flora and fauna, a planet-wide jungle where the sun never quite broke through the mist. That image died a sudden, violent death on the 14th of December, 1962. NASA's Mariner 2 became the first spacecraft to successfully fly by another planet, and as it approached that glowing orb, it turned its microwave radiometer toward the clouds. The data that streamed back was the end of the swamp theory. Mariner 2 revealed an infernal surface temperature of approximately 460 degrees Celsius. To add to that, the probe's magnetometer found no evidence of a planetary magnetic field. Without a magnetic field, Venus didn't have a shield to deflect the sun's harsh solar radiation. It was being stripped bare and cooked from the inside out. And the narrative of Venus shifted, with scientists like Carl Sagan using it as the ultimate model for the runaway greenhouse effect.
Even though it's only a little bit closer to the sun than the Earth is, the greenhouse effect is almost entirely responsible for this high temperature.
It went from being the sister planet to Earth's evil twin. While the Americans were content with flybys, the Soviets had a different approach. They decided they were going to touch the ground no matter how many probes they had to sacrifice to do it. The Venera program remains one of the most brutal engineering challenges in history. Most of their probes were essentially kamikaze missions. They would hit the Venusian atmosphere at a staggering 7 miles per second, deploy their chutes, and begin a slow descent into the unknown. As they dropped, the air wouldn't just get hot, it would get dense. On Venus, the atmosphere is 96% carbon dioxide, which means it behaves less like air and more like fluid. Descending through it is like sinking into an ocean. For the early Venera probes, this was essentially a death sentence. They were crushed like tin cans. It took just over a decade of failures before Venera 9 finally survived the descent and lived just long enough, about 53 minutes, to send back the first photo ever taken from the surface of another planet. Venus was a jagged, light-starved graveyard of volcanic rock. The sky was a sickly orange-yellow, and the horizon was blurred by a thick, corrosive haze. To the scientists of the 70s and 80s, the conclusion was obvious. Venus was geologically dead. But it turns out, we were looking in the wrong place. Before that, let's quickly hear from today's sponsor. We often explore the future of humanity and the idea of living beyond Earth. But what if the real challenge wasn't building a home on another world, it was rebuilding our own after a series of catastrophic events? To do that, we would need the book, The Ultimate Guide to Rebuilding Civilization. They say you shouldn't judge a book by its cover, but this one makes a very strong first impression. And when you open it, you realize it's not just a guide, it's a celebration of the entirety of human civilization. Whether you simply enjoy learning how things are made and how they work, or like to take apart the very systems that have propelled our species forward, there is something in here for everyone. Within these beautifully illustrated pages are detailed diagrams on everything from materials to building to industry. Anything humans have made or engineered is in here. Also, it contains a hidden quest, a secret puzzle that adds a layer of interactivity. I've been reading it for about a week now, and it's a really well-made piece of work. It's also the kind of thing you'd gift yourself, or that one friend who's impossible to shop for. Check it out at the link in description, and use the code TERRITORY for 10% off. For the last few years, the dead planet had started to show signs of a pulse. In 2024 and 2025, astronomers began noticing anomalies in thermal data, hints of active volcanic vents on Mont Mons, a massive shield volcano that towers over the Venusian plains. In early 2026, researchers at the University of Trento decided to revisit the data from NASA's Venus mission of the 80s. The Magellan was the first spacecraft to map the entire surface of Venus using synthetic aperture radar. Because you can't actually see through the clouds with normal cameras, Magellan bounced radio waves off the ground to see the terrain. It gave us our first look at pancake-shaped domes, miles of lava channels, and tectonic fractures. However, Magellan's technology was a product of the late 80s. The images it produced, although revolutionary, were limited by the hardware. You could recognize the shapes, but the fine details were lost in radar noise. By applying denoising algorithms to this 30-year-old data, the team at Trento managed to clear the static. And in that new clarity, they spotted a feature that was once thought impossible to find on such a volatile world: a skylight-like opening. On the western slopes of a volcano called Nix Mons, the sharpened images revealed a perfect, dark, circular pit. It wasn't an impact crater, but the entrance to a lava tube. On Earth, a large lava tube, like those in Hawaii or Iceland, might span barely 0.02 miles across. On the Moon, where the gravity is much lower, they can reach a staggering 0.3 miles in width. But on Venus, this newly discovered tunnel is estimated to be over 0.6 miles in diameter. How does a structure that massive even exist without collapsing? The answer lies in what we call the Goldilocks zone of Venusian physics. Venus has surface gravity very similar to Earth's, which helps with structural integrity. But it is the atmosphere that does the heavy lifting. Because the air is 90 times denser and incredibly hot, it acts as a perfect insulator. When Nix Mons erupted millions of years ago, the lava didn't just flow and cool like it does on Earth. It had to fight against the crushing weight of the air. The heavy, superheated atmosphere forced the outer shell of the lava flow to crust over so perfectly, it formed a self-insulating pipe. And inside this pipe, the molten rock stayed liquid for much longer, flowing for hundreds of kilometers. When the eruption eventually petered out and the lava drained away, it left behind a reinforced basaltic cathedral. On Earth, these structures are temporary because rain seeps into cracks, rivers carve them out, and eventually they collapse. But Venus doesn't have water-based erosion. And while the atmosphere is heavy, the surface winds move at a walking pace. This discovery forces a massive narrative shift in how we view our sister planet. For decades, the surface of Venus has been seen as a death sentence for any technology we dare to send there. But 150 meters beneath that basalt roof at Nix Mons, things are different. While the crushing pressure of the atmosphere remains, the roof provides a natural, impenetrable shield. It protects the planet's interior from the intense heat and radiation of the sun. If humanity is to ever have a future on Venus, a prospect I mention with extreme hesitation because it is still very much a hellish world, it will be found here in these ready-made, naturally armored bunkers. Inside these tubes, the environment is stable. And so we have gone from seeing Venus as a jungle to seeing it as a graveyard for our probes, to finally seeing it as a foothold. And perhaps the most exciting thing about these lava tubes is what they prove about the planet itself. You only get open tunnels like these if a planet is still alive inside. It means Venus isn't just a cold, dead rock. It is moving, hot, and changing deep beneath those thick clouds. This discovery changes the entire mission for the next decade of space travel. When missions like Veritas and Envision arrive at Venus later this decade, They won't just be mapping mountains from a distance, they will be hunting for these specific doorways. These massive underground vaults, which have been sitting in the dark for millions of years, perfectly preserved and waiting to be found. What do you guys think? Let me know in the comments below. And don't forget to like, share, and subscribe to Territory, because this is your space.